Howdy, it's Tubal Cain again, and this time with episode number 15 of my What Makes It Work series, entitled How a Pressure Gauge Works. So let's take a look at what makes a pressure gauge work. And most gauges of this type, which we call a board-on tube, are very similar in construction. So let me take this one apart and talk about how it's constructed. This is quite an inexpensive gauge. Some of the better ones are going to be sealed, maybe even stainless steel, and filled with glycerin to lubricate and to keep the needle from vibrating. But I simply took off the front ring, which was pressed on along with the lens, and on the back were two screws, which I've taken out. Just a protective cover is all that is. And the entire mechanism here is brass, with the exception of the copper tube here, which is we call the board-on tube. And on the front, of course, there's a needle, and it's been calibrated with a little, and it has a little stop peg there, and the face. And this gauge goes from 0 to 100 psi, pounds per square inch, and you can tell this is kind of an old one, because the newer ones are also going to tell the pressure in metric, which is kilopascals. The board-on tube is nothing more than a piece of copper tubing that has been flattened and then bent into a circular formation here, and it's soldered to the the square brass part right here, just soldered, and then it's also soldered on the other end so that it is leak-proof, in other words, airtight. Now when the pressure comes on, the board-on tube attempts to straighten out. Now it's not going to go all the way, it's only going to flex a little bit, and in some ways it's similar to a party whistle. Attempting to straighten up and always returning to its original position. Now watch the needle as I turn the air pressure on and then again off. We're at 90. Now watch the board-on tube as I turn the pressure on and off. On, see it, try to straighten up, off, and it relaxes. Pressure's on, pressure's off. From this view you can see this small link here is fastened onto the end of the board-on tube, permanently fastened, and then there's a pin here, and then this link here links it all to the movement. So watch now again as I pressurize it again, and you can see what the linkage is doing. Here comes the pressure. So that motion is transmitted through the linkages and into the quadrant and into the pinion, which in turn moves the needle. And I'll show you another view of that. Never before seen on YouTube. Now I'm straightening up the board-on tube with my fingers, bringing it clear up to 100. And by the way, it takes considerable pressure to do that. But there's a movement in here. I don't know if it's going to show up or not, and it won't do any good to take the face off. I was going to take the face off. But down here on the shaft that goes to the needle, there is a tiny gear that we call a pinion. Also there's a little spring right here too, a hairspring. And this is the quadrant here. That's another gear that engages with that little pinion. And as this attempts to straighten out, you can see there's a linkage here that goes to the quadrant, which in turn is spinning the needle, turning the shaft. It's a complete brass movement, made in USA, by the way. It must be pretty old. Now we've got some linkages here, or some links. There's a link right there, and yet another one here that looks a bit like a loop. Now the reason for the loop, from what I understand, is to allow them at the factory, when they built this, to calibrate it. In other words, so that, well, they got a little peg here for the 0, so they don't have to worry about that. But they would bring it up to perhaps 50 and calibrate it on a machine and adjust it here with that little loop by either squeezing it or spreading it, and that would change the calibration there, so that they could check it perhaps at 50 and again at 100 to see that this is a quality piece and is within their standards, or their of what they require on their blueprint. And in a cheaper one like this, maybe they're just close enough at 1 or 2 or 3 pounds, I don't know. But in a laboratory grade, it would be much more accurate. But on the average compressor, it just isn't that critical. From this angular view now, can you see the quadrant there? Quadrant meaning 1/4 of a gear, but I don't know if that is 1/4 of a gear. Riding on the little pinion and turning the shaft. Did anyone ever show you this before? I used to do this when I taught welding with an acetylene gauge. I blew that party whistle. That was the entertaining part for a high school class. Well, that's it, folks. That's how a pressure gauge works with a board-on tube. Hope you enjoyed it. Leave me a comment if you like this, and be sure and watch my other videos, and in fact, I'll see you in the next video. This is Tubal Cain saying so long for now.
Hey guys, welcome back to the another video of Engineers Academy. So guys, on our channel Engineers Academy, we do post educational videos. If you haven't subscribed yet, please do subscribe it now. So guys, let's begin with our today's topic. Our today's topic is the temperature measurement systems, which is used in the industrial applications basically. So let's begin with our today's topic, that is temperature measurement systems. So guys, whenever we talk about temperature, there will be the change in temperature in the industries. There will be sudden rise in temperature, or the change like the decrease in temperature basically. So guys, we need to measure that change, that is the increase and decrease in the change. So this change can be occurred due to the external heating, it can be occurred due to the frictional, also it can be occurred due to the process equipments or by the means of mechanical equipments, guys. So and in the industries this is very common, and we need to check and we need to measure this change in temperature basically. So guys, this is the traditional method over here. This is the by using this mercury filled thermometer, which is a traditional method to sense the temperature basically. So over here the sensing media is nothing but the bulb which is filled with the mercury, and the mercury expands in a tube basically, which is having scale markings. So guys, this is the traditional method, but we are over here talking about this industrial temperature measurement system. So guys, there are two types of industrial measurement. The first one is the mechanical temperature measurement system, and the second one is the electrical temperature measurement system. So guys, whenever we talk about the mechanical, we can deal with the physical aspects, such as the time temperature is directly proportional to the change in length or change in structure, that can be expansion or contraction basically. So, and in the electrical temperature measurement, there are some of the electrical parameters such as the change in resistance or in a conductance, etc. So guys, first of all, let's begin with the mechanical measurement system. So guys, over here in mechanical, the first one is the bimetallic temperature gauge, which is also known as a bimetallic thermometer. So over here, this bimetallic term which is used, which is due to this bimetallic strip over here, which is used inside for the primary sensing element. So guys, over here two dissimilar metals which is used and which is fused and joined together in the form of this bimetallic strip. So guys, over here we can see this bimetallic gauge over here. So this is the basically primary sensing media, which is the bimetallic strip used in a helix form with some of the mechanical arrangement. So guys, this is the first case, that is the first scenario. The temperature outside is like very less, or we can call it as ambient temperature. So guys, inside that ambient temperature, this bimetallic strip is at the not expanded yet. So over here in the second case, you can see that after heating, after the change in temperature, it get expanded over here. So guys, this bimetallic strip, due to that expansion, it shows the reading on a scale through the pointer basically. So this is the basic principle of this bimetallic temperature gauge. Moving ahead, next is the gas filled temperature gauge. So instead of bimetallic strip over here, which we have used this primary sensing bulb over here. So guys, this particular sensing bulb is filled with the sensing gas basically, which we can call it as a inert gas. So typically nitrogen is used, this inert gas is used as a nitrogen. So guys, whenever this sensing bulb undergoes the temperature change, or wherever there is a increase in a change, the gas which is used inside that sensing bulb, it expands, the inert gas gets expands, and it gives us the reading through the expansion of this Bourdon tube on a scale through a pointer basically. So this is how the gas filled temperature gauge works. So it gives a reading on a pointer. So the internal mechanism is somewhat same, but the sensing element is different. So guys, this was the mechanical measurement systems over here. So now let's check out the electrical temperature measurement system. So guys, over here in electrical temperature, we are dealing with the resistance, we are dealing with the capacitance, inductance, all these electrical aspects basically. The first one is the RTD, that is the resistance temperature detector. So guys, from this name resistance temperature detector, we can conclude that